Welcome back. In the next part of this lecture, we'll find some values of our trig functions at multiples of 90 degrees, and we'll also talk about quadrants and how those affect the sign of our trig functions, whether it makes them a positive value or a negative value. So first off, let's start with these problems, finding our exact values of these trig functions. And you'll notice here I say if they're defined, because remember that 4 out of our 6 trig functions can be undefined depending on where our angle happens to be. So first off, for all of these, I'm going to begin by drawing my angle. Remember that we've defined our trig functions in terms of taking a point that's on the terminal side, finding r, the distance from the origin to that point, and then in terms of the x-coordinate of the point, the y-coordinate, and r, that's how we've defined all of our trig functions. So that means that if I wanted to find sine of 90 degrees, the first thing that I would do is start by drawing 90 degrees, and I know that 90 degrees would be here, ending on the positive y-axis. And I can take any point that I'd like, so I'm going to be really strategic here and choose the point 0, 1, choosing some very nice numbers. I also know that r is the distance from the origin to that point, and no surprises here, we are 1 unit away from the origin, so we know that r is 1. Of course, if you didn't think about that, you could of course find the value of r being 1 using the formula that r is root of x squared plus y squared, and that indeed does give you a value of r of 1. So now something like sine of 90 degrees is easy enough to find because that's y divided by r, and the y value is 1, the value for r is 1, so sine of 90 degrees is 1. I can use the same drawing here for tangent of 90 degrees. Tangent of 90 degrees we know should be y divided by x. And here the y value is 1, but the x value is 0. And that means that tangent of 90 degrees is undefined. So there we go. This is our first example of a trig function not having a value for a particular angle. So for 90 degrees, tangent would be undefined, and the reason it's undefined is because tangent is y divided by x, and since x is 0, we're dividing by 0, that's undefined. Let's do some more. Secant of 0 degrees. So for this, of course, I'm going to find that as the reciprocal of cosine. So really what I'm going to think about is what is cosine of 0 degrees? So 0 degrees would be me starting on the positive x-axis and ending on the positive x-axis. So 0 degrees, there we go. Take any point on that terminal side. Since it's 0 degrees, where we begin and where we end are the same side, so I can take any point that I'd like on the positive x-axis. I will take the point 1, 0, and you can see that we are 1 unit away from the origin, so r is also 0. R is also 1. And again, you could find that using the formula. R is square root of x squared plus y squared, or root of 1 plus 0, which is 1. And now, let's answer our problem. We know that cosine of 0 degrees should be the x-coordinate over r. The x-coordinate is 1, and r is 1, so cosine of 0 degrees is 1. And since secant is the reciprocal of cosine, then secant of 0 degrees should be the reciprocal of 1, which is also 1. So there we go. Secant of 0 degrees is 1. For the next problem, this is where we're starting to mix in some radians just for fun. So you might have to, on the side, figure out that 3 pi over 2 is the same thing as 270 degrees. So really, when we say cotangent of 3 pi over 2, we're saying cotangent of 270 degrees. And we know where 270 degrees would be. That would be over here. So there's my angle 3 pi over 2. And I can take any point that I'd like, and I'm going to take the point 0, -1. And same thing with all of these. I've chosen all of these points to be 1 unit away from the origin just to make my work a little bit easier. So I have my point. I know the value of r is 1. And I know that tangent of any angle is y over x. And so that means that cotangent should be the reciprocal of that, which is x over y. So in this case, if we're looking for cotangent of 3 pi over 2, that should be the x-coordinate over the y-coordinate. So cotangent of 3 pi over 2 should be the x-coordinate over the y-coordinate, 0 divided by -1, which is 0. There we go. So we've got ourselves cotangent of 3 pi over 2, or in other words, cotangent of 270 degrees is 0. One last one. So again, we're in radians. Cotangent of pi, we know, of course, pi radians is the same thing as 180 degrees. So if we're looking for cosine of pi, we're really looking for cosine of 180 degrees. And we know where 180 degrees would be. That would be on the negative side of the x-axis. And so now I'm going to take my point, and I'll take the point -1, 0. That'll be the point that I choose. Again, I'm not saying that you have to choose that point. You could have chosen -2, 0 if you wanted, or any other point, as long as it's on the terminal side. And we know that our terminal side would be on the negative side of the x-axis, so any point on that side would work. I'm choosing the point -1, 0 just to make my arithmetic easier. And again, we can find that the value of r should be 1. We're 1 unit away from the origin, or you can use the formula. And we're ready to go because cosine of pi should be the x-coordinate over r. The x-coordinate is -1 and r is 1. So cosine of pi is -1. All right, so the next thing that we want to talk about is what does it mean for two angles to be coterminal? Coterminal angles, those are angles that have the same terminal side. So that would be, in other words, they would be angles that differ by a full circle or a complete revolution. So, for example, 100 degrees and 460 degrees are both coterminal to each other because if you're thinking about 100 degrees, that would be starting on the positive x-axis and ending somewhere over here, a little bit past 90 degrees. That would be 100 degrees. But you could also think of it as 460 degrees if you started at the initial side, did one full revolution, that's 360 degrees, and then did another 100 degrees after, that's 460 degrees. So both of these angles have essentially the same terminal side. They look the same. That means that they would have the same x and y coordinate for whatever point you picked on that terminal side, which also means that all the trig functions should be equal for those two angles. So if you're looking for sine of 100 degrees, that should be the same thing as sine of 460. Same thing for cos, for tangent, and for all the other trig functions. So that means that if we're looking for some exact values here of our trig functions, we can find them if we're thinking about the fact that these angles, 390 degrees, or the other one, 13 pi over 6, that they're both equivalent to, or coterminal to rather, some nice angle that we've already seen before. So in the case of 390 degrees, we know that 360 degrees would be a full revolution. So if you started at the on the positive x-axis and went all the way around, that would be 360 degrees. And so then 390 degrees would be going 30 degrees further. So if you went one full revolution plus 30 more degrees, that would be 390 degrees. So since those two angles are coterminal, then we know that sine of 390 degrees should be equal to sine of 30 degrees. And for 30 degrees, we know what to do there. We have our special triangle, the 30, 60, 90 triangle. So for sine of 30 degrees, sine of 30 is, in terms of our right triangle, would be opposite over hypotenuse. And so for 30 degrees, the opposite side measures 1 and the hypotenuse measures 2. So sine of 30 degrees is a half, which means sine of 390 degrees is also a half. For 13 pi over 6, this is again something where you might have to do a little bit of a calculation on the side. So if you do find out that 13 pi over 6, if we were to multiply it by 180 over pi and simplify it, you'd find that yes, indeed, that this is equal to 390 degrees. So we're really still talking about the same angle that we were in part A, 390 degrees. And so we also know then that tangent of 390 degrees, or 13 pi over 6, that 13 pi over 6 is coterminal to 30 degrees, or pi over 6. So there we go. Tangent of 390 degrees is equivalent to tangent of 30 degrees. And for 30 degrees, we know tangent is opposite over adjacent. So tangent of 30 degrees, tangent of pi over 6 should be 1 over root of 3, which in simplest terms is root 3 over 3. So the other part that we wanted to talk about in this section was about the different signs that sine, cosine, and tangent and the other trig functions can have. So we noticed in the last video that depending on the angle, some of these trig functions might be positive and some of them might be negative. And that really depends on what quadrant we're in, because depending on the quadrant that we're in, the x-coordinate on that terminal side might be positive or might be negative. And depending on whether x and y are positive or negative, that'll affect whether the other trig functions are positive or negative. So the one thing to remember here, of course, is that r is always going to be positive. And the other two values, x and y, those are the two that could be positive or could be negative. So if we're thinking about quadrant 1, for example, in that quadrant, the x-coordinate would be positive, the y-coordinate would be positive, and we know that r itself is positive. So no matter which trig function we're looking at, whether it's sine, y over r, cosine, x over r, tangent, y over x, this would all be a positive number over a positive number. So all of these trig functions, they would all be positive in quadrant 1. In quadrant 2, the x-coordinate is negative and the y-coordinate is positive. So if we're thinking about our trig functions, sine, which is y over r, that would be a positive over a positive. So sine would be positive. Also, of course, cosecant, since that's the reciprocal, should also be positive as well. But the other four trig functions would also be negative. Cosine of theta, x over r, that would be a negative divided by a positive. That would be negative. Same thing with secant, since that's the reciprocal of cosine. If cosine's negative, so would secant be. Tangent would be y over x, a positive divided by a negative, which is negative. And similarly, cotangent, since it's the reciprocal of tangent, it should also be negative as well. So we discover here that in quadrant 1, everything was going to be positive, but in quadrant 2, sine is positive and also cosecant. And you could make similar sorts of discussions about quadrant 3 and quadrant 4. In quadrant 3, you would find that tangent is positive and also cotangent because it's the reciprocal. In quadrant 4, you would find that cosine is positive and also secant because secant and cosine are reciprocals of each other. A way that we can remember this, there's a couple of different ways. Some books will refer to what they call the cast rule, because if you take the first letters of each, C-A-S-T, it spells the word cast. Another way of remembering these is the little acronym, all students take calculus. That's usually how people remember which quadrant is which functions are positive. So in quadrant 1, everybody's positive. Quadrant 2, sine and its reciprocal. Quadrant 3, tangent and its reciprocal. And quadrant 4, cosine and its reciprocal. That, of course, means that in quadrant 4, everybody else except for cosine and its reciprocal would be negative. In quadrant 3, everybody except for tangent and cotangent are negative. And in quadrant 2, everybody except for sine and cosecant are negative.